Hey guys, good morning. It is Wednesday. Have a blessed and beautiful Wednesday. And it is April 29th, Module 7.3, Activity 1.2. What does it mean to burn calories? So we're going to just talk about calories and what that actually means. Before we do that, we're just going over a couple of vocabulary words. The first one being energy. Energy can make things happen. Power is derived from biochemical reactions in our body. That is where energy comes from, the biochemical reactions in our body. And how do we get that energy? From food and oxygen. When that food and oxygen mix, it causes a chemical reaction or a biochemical reaction, also known as metabolism, which is your third word. And that's where we get our energy from in our body. A calorie is a unit of energy widely used in nutrition. I know you guys see calories on food cans, just any type of food. It will give you the caloric intake. And a calorie, again, is just a unit of energy in that nutrition. Metabolism is the actual chemical process that occurs in order to get that energy. So the chemical process that occurs within us in order to maintain life. We need energy to maintain life. That metabolism is what takes place in each of those cells that gives us that energy. And again, biochemical reaction is the chemical reaction that takes place within an organism, also known as metabolism and energy. Please remember, a chemical reaction happens in the body when you eat. This is when food molecules react with oxygen to provide energy for the cells. So you've got your food, and as you can see the green arrows, you're taking food in, you're breathing in oxygen. All of that causes a chemical reaction in your body. And what do you release? You release what the body did not use, which is your carbon dioxide, and any energy that you need, you're able to release it. So that's even with just your eye movement, moving your hands, talking, moving the mouth, walking. Any type of movement is using energy. Even when we sleep, we're using up energy. And where do we get that energy? From food and oxygen. Making predictions. Is there more or less oxygen in the air that you exhale than is in the room before you exhale? So we're talking about actually being in a room. You can be in your bedroom, in a classroom, anywhere. When you're in that room, when you exhale, does it cause the amount of oxygen to change? Does the oxygen level in the air change? Think about that. The second part is there more or less carbon dioxide in the air when you exhale? Now, I know that first question you're thinking, wait a minute, do we exhale oxygen? I thought we only exhaled carbon dioxide. So those are things that you need to think about. Does the air change in that room as you're breathing in and breathing out? Let's look at a video about the concentration, which is the amount of oxygen and carbon dioxide in the air when you inhale and when you exhale.
Nature's balance, oxygen. All living creatures breathe in oxygen and give out carbon dioxide in order to live. Plants take in carbon dioxide and release oxygen. Animals take in oxygen and release carbon dioxide. Plants make their own food. They absorb carbon dioxide in the air and water from the soil. Leaves contain chlorophyll, which uses sunlight as a source of energy to break down carbon dioxide and water into food. Oxygen is released during this breakdown. This process is known as photosynthesis.
So please note in this area, and they did show it before in the video as well, When we breathe in oxygen, which is O2, and we release carbon dioxide, which is the CO2. Plants and leaves are exactly the opposite. They take in the carbon dioxide, which is the CO2, they take that in, and they mix it with their food and sunlight, and they release oxygen. So, oxygen is actually being released from plants and trees, and carbon dioxide is being released from humans and animals.
Will we ever run short of oxygen?
That's something to think about. Will you ever run short of oxygen? So, where do we get that oxygen from? Again, we get it from plants and leaves. That's what cleans our air. We get it from other sources as well, but that is our main source of oxygen. So, will we ever run out of oxygen? And that was supposed to continue playing, so I apologize for that. Let's just go back to the video for a second. Where we left off.
Will we ever run short of oxygen? If deforestation continues at a rapid rate and no more new trees are planted, it could lower the supply of oxygen.
So again, it said deforestation, which is what you see in the picture. It will lower our source of oxygen. Does it mean we'll run out of oxygen? No, but it will definitely lower how much oxygen we have. So note, humans and animals, as we said, inhale oxygen and we exhale carbon dioxide, whereas plants and leaves take in or inhale carbon dioxide, if you will, and they release oxygen. So they're completely opposites of each other. When we inhale, we actually only inhale 21% of oxygen. That is the oxygen level that we're inhaling. By surprise, we are actually taking in some carbon dioxide as well. When we inhale, there is a small, very small percentage, 0.04% carbon dioxide being inhaled. Now, when you look at these percentages, this is nowhere near 100%. So you might be thinking to yourself, well, wait a minute, that's not 100%. So what are we actually inhaling? We're inhaling other gases other than oxygen. And the main gas that you're inhaling is called nitrogen. You're actually bringing in about 75, a little bit more than that, percent of nitrogen mixed with other gases. And oxygen actually only makes up 21% of that. But your body uses that oxygen. When you exhale, you're actually exhaling oxygen. So in your mind, you're thinking, wait a minute, don't we exhale carbon dioxide? Yes, you do. But you also exhale oxygen. Whatever amount of oxygen that your body did not use when you inhaled, it goes out when you exhale. So you inhale 21% oxygen and you actually release 15% of that. Your body only literally needed or held on to 6% of that oxygen. Now, when you inhaled carbon dioxide, that was a very, very low percentage. But when you actually exhale the carbon dioxide level, it's much more and it becomes a waste, and that is 4%. So you're releasing 4% of carbon dioxide. And again, there are other gases that we inhale and exhale. You guys will learn about that more in higher grades when you get to high school. All right, so what will we do today? We're going to burn or watch a video of a burning tortilla chip. And what you're thinking about is, will the levels of oxygen and carbon dioxide in the air change when you burn a tortilla chip? So you're just thinking about the levels of air around that chip. And does it change? Does it change the oxygen in the room? Does it change the carbon dioxide in the room? Here's a question for you to think about. What evidence would you expect to see that energy is part of the reaction as the tortilla chip is burning? So you're thinking about energy and you're looking at an item, you're looking at something burning. When you hear the word burning, what do you think of? You think of a fire, you think of smoke, you think of a flame, right? So the higher the flame, the more energy that's being produced. So those are the things that you want to notice when you're looking at a tortilla chip burning or just anything burning for that. So part of the evidence would be seeing a flame, seeing some smoke. How big is the flame? Did the color change? Did the odor change? All of those would be evidence that a chemical reaction is taking place and that something is in fact burning. So our demonstration video, we will watch a demonstration that will burn a tortilla chip to learn more about how burning outside of the body and burning calories inside the body compare. And please do not do this at home, guys. All right, so we're just going to watch the burning tortilla chip. You notice the color is changing. You see flames, nothing big, definitely small. It's not something that burns quickly or easily. It takes a moment to burn. And if you can notice it, the flame is very, very low. Very low. All right. So levels after burning a tortilla chip, your oxygen level is significantly less than that 21% that you started off with. It doesn't hit zero, but it's definitely significantly less. The carbon dioxide is actually significantly higher. When you actually burn with that fire, with the flame, it's actually releasing more carbon dioxide than what you initially started off with, or than what we actually breathe out. Because it's an open system, it's a chemical reaction in an open system, it's very hard to measure the exact percentages, but just know that that oxygen level changes drastically, and so does the carbon dioxide level. They change drastically. All right, so at this point, we're actually finished with the slides. And what you're going to do is go into your Google Classroom, and you have two assignments there. You're going to do one on quizzes, which will be posted, and it's oxygen and carbon dioxide. After you do that, and I believe it's 10 questions there, and then you're going to go into your classroom, and you are going to look at, I believe it's on Google Forms. So Ms. Jones can find it. It's probably this one. Nope, it's not. Well, anyway, it's posted in your classroom. It's on Google Forms. And I believe that one has 4 questions. And it's about understanding metabolism. So please just complete all of that work. And you know the work that's posted now for today will be due tomorrow at 11:59 p.m. So remember, there is an assignment that's due tonight at 11:59 p.m., which was what was posted yesterday. Today's post is due tomorrow, which is Thursday at 11:59 p.m. Please make sure you're getting your work done. I don't want to have to send out any emails. I don't want to have to make any phone calls. Please, this is our last quarter. Let's get that work done. And I will see you guys tomorrow in the classroom. In the classroom. Hey, what we doing in the classroom? Thanks, guys. Have a good day.